Hello everyone, welcome to our fourth episode of DevStandup. And guys, one thing is that due to some vacation issues, our guest speaker had to reschedule our episode for the later weeks. But our default speaker again, Atakan, today he's gonna present again one of his topic that gonna be interesting. And without wasting any time, I would like to give the floor to Atakan that he can talk about his project. So Atakan, floor is yours. Let's hear your thoughts.
Hello everyone, I'm Atakan Basaran. I'm back for the fourth episode of DevStandup. I'm glad to be back. So today I would like to talk about using WebAssembly with Golang. So let's first start with what WebAssembly is. WebAssembly is essentially a bytecode that's an instruction set that's compiled and runs at the near native speed in the browsers. Because it runs on the browsers, it's portable across all the platforms because you only need to have a browser that supports it, so you can essentially write one runs anywhere. And you have multi-language support because this is essentially architecture that the language needs to compile with. So you have the support from C, C++, Rust, and Go, and more for the WebAssembly. If you look at the toolkits today, you have the option to use the C and C++ with the mscripting, where they have support for browser APIs already and JavaScript interrupt already built in. You also have the WASM. This is not for the browsers mostly, but this is for if you have a project that is like a POSIX compliant using POSIX libraries, you can use it to compile it and you can use it to run on Node.js or also on the browser as well. But project is mostly focused on running it on the Node.js and other runtimes. You have the Go, which if you can use the Go to compile to the WebAssembly with the WebAssembly target. This, however, will come with limitations, which I will explore future, but you can use the Go to have the WebAssembly project. You also have the WASM Bingegan, which is the Rust toolkit for compiling the Rust to the WebAssembly, as well as having the binding between JavaScript and Rust figured out. So before continuing, I just want to talk about the use cases that we had and how we end up with the WebAssembly. So as for the familiar people that's following on the other episodes, we had a talk about we were having a progressive web app application that we are using Capacitor for running it. So Capacitor essentially runs your application in a web view. So you can use a JavaScript, but so to this application, we wanted to add some sticker system for the share feature. So initially, the solution we went was you have the photo, you have your Capacitor application, you render the photo with the HTML canvas, and you'll have your results. This worked well until it didn't, because as it turns out, having multiple complex shapes for the HTML canvas was not real performant. So our first idea was, let's make a Capacitor plugin, which will, you have all your you have your picture, you have the parameters that you want where the stickers are gonna be, and like a map of the stickers and everything, the text and everything, and render them on the native side, then return back the application the final result. This is maybe the fastest approach. However, as I mentioned, for this application, since it was a side project, we don't have the manpower or time to spend to develop two different sets of plugins, one for the iOS and one for the Android code base. So then we use the next best solution available, which is WebAssembly. Since this Capacitor app is running on a web view, it can load the WebAssembly. So the solution that worked for us was with the near speed was having the photo go through this Go WebAssembly application with all the stickers and the filters, then returning the final results. So on this one, we use Go. If you talk about the Go and how it works with the WebAssembly, is you essentially use the JavaScript as the Go OS arc, which is the operating system that you're compiling with, and the WebAssembly as the architecture, which is the CPU architecture that you're compiling with, which will generate you the WebAssembly files right away to use on the JavaScript environments and the browsers. Go has actually the WebAssembly is a first class support on the Go, so you have the syscall.js package to call JavaScript functions from Go, or you can expose the Go function to JavaScript. How this interop works is you have this WebAssembly exec file which is bundled by on all the Go installations. I will show you where you can find it on yours. And this one essentially takes your binary, does all the binding with this JavaScript world and the WebAssembly world, and allows you to use it pretty much without touching anything. However, there are some limitations since the Go has this concurrency and everything. Even though you can use those, they are not parallel. They are still single threaded, and you have some of the browser APIs like the fetch and DOM. You need to do a lot more passing through the WASM exec binding. Like you need to bind your functions on JavaScript side and call them on the Go side, because not everything, not the whole DOM objects are exposed, but there are libraries to get around with that. So without further ado, let's have a small hello world application. So if I remove these, so this is your typical Go application. You have you can import the syscall.js, where you have the option to define a global function. So if I remove this and I say like JavaScript global, and I said like on the global, this is like the window top object, set the hello world as a function that is bind to here. So in here now I have the JavaScript value, which is the instance of itself, and the arguments. So these arguments are, if on the JavaScript side, if this function is called with like this would be the argument 0 with test, argument 1 would be 1, 2, 3. But in this example, first I want to just return hello to this hello world function. So just one small quirk in here, which you should you should always remember, is in the eyes of the WASM exec, only the main function is run, because that's how the Go applications work. So you need to keep your Go application alive by running an infinite loop to keep it alive. Otherwise, the application will just run and quit. So how I'm going to get this compilation is, so as you see, I will just compile this file with the Go.js and the Go WebAssembly with just the output defined as the main.webassembly. Now it's quickly compiled, and this is where you can find that WASM exec JavaScript file. So this is usually located at your Go root folder. As you see, for me, it's user local Go. So in there, it is under lib WebAssembly exec. So you can use this small macro to just copy it to your folder. And here we are. I have it in here. It is like it's managed by you. You don't need to touch to this file. This is just for bootstrapping everything. This is like bundled by the version of the Go that you have. So on your index.html or the HTML file or your project, so I have some other examples to show the use case, but for this hello world, well, let's focus on this code block, which is in here. We just import our WASM exec.js, and we essentially create a global object called Go. It's a Go class, and we can load it. This is defined by this WASM exec file, and this WebAssembly is also defined by the WASM exec file. You can then load your WebAssembly file. You can set the import objects, and you can then eventually run your file. So this Go run result instances essentially just starts the project, your Go project from here. So I had a web server here. If I reload, right now actually, if you go to the network tab, you see that the WASM exec file is loaded, and my WebAssembly file is also loaded. So in theory, I should be able to run hello world and get the hello back. So this is coming from Go in here. Let's say I want to have the name in here. So I say arg0, and I want to have it as a string, and I say hello name. So I compile this project again, then I reload it. So now I have hello world DevStandup, let's say. And now, as you see, this reply is coming from the Go, like the Go project in the WebAssembly file. And you can also pass and return functions. So pass and return parameters. And use them as the variables in your functions. So in our case, we wanted to have since this, the reason we used was for the image, we wanted to have a function called like apply filter, apply sticker, and stuff like that. So in this example, I would just go with the apply filter. So we essentially have a apply filter function with the base64 data as the input 1, and the filter selected as the argument 2. So, and now to just as a debug to return it, we can just say you can also use the format print line. This will bind it to the console log, so you can say applying filter to base64, and I would like to pass the base64 file I passed here. So now I can just rebuild it, and it brings us to our other HTML files. Essentially, this is just a small like a HTML page where I have an image input. When the image input changes, I also show the original one on the left side, and when the user presses apply the filter, user has some selections for the filter type, like grayscale and invert. And when the user says, okay, apply the filter, essentially we read the original file, return it to the base64, make it cast it to base64, and call our function as apply filter base64 and the filter. So this one, this is we set it on the global, this is applied as a global level, so you can just call it the apply filter. So just to test it, as you see, when I go and load our scenery file, right now there is no filter is going to be applied, but as you see, I got the applying filter grayscale to base64 this. So our Go application received this file and the option that we selected. So for applying on our project, for applying this image manipulation, we use this library, this integration gift. So you can just load it by go get and get this library. And I already have a sample setup here, so I will just switch this to that. But essentially, in here we got our base64 input, we got our filter, and we apply our filter in this function where we essentially just convert this base64 data back to an image in the Go world, apply the filters, draw it to the buffer, then we return that buffer as a base64, and we return this as a string back to the function that called it. So when I compile it in here and refresh my page, see, now I have this image, and instantly I can make the grayscale one, I can invert it, and I can apply much more. I can extend this to apply much more things, get parameters, and even fetch some external things in the Go world to pull and use it on these images. So that was pretty much it. That's how we tackled this whole problem and this is kind of how we started at the beginning. Now on our application, we have the sticker system coming up where we passed the JSON objects where the things could be, and we replaced it. But the main idea was doing this as fast as possible in the WebAssembly world. So I hope that's give you an idea. That's all.
Yeah, Atakan, thanks a lot. I got like one question is that how this Go runtime management handles the WASM applications? Like, does it affect the performance, or can you tell me about this a bit?
Yeah. So essentially, it's up to like since there are each browser handles the WebAssembly a bit differently, but in the recent years, I think even on the mobile ones, there is a full support, like a mature support. So the impact to the web page should be minimal these days. So yeah, it should be pretty fast.
And also, like another question is that let's say if I want to build some, let's say, graphics heavy application in Go, like would you advise like using this WASM in my application, or it's not advisable for such applications?
Yeah, actually, like I don't know, the Go maybe it's up to your favorite runtimes, but like the favorite language. But for the WebAssembly, yes, it is advisable. I think like there are some blog posts on the Shopify how they switch some graphic heavy parts of the like rendering heavy parts of the page to this WebAssembly, and they saw a massive improvement in the page loading because it handles this graphics like they were all doing the canvas calls like a bazillion of them because to load the images on these products and everything, and they saw like a 50% increase on the performance when they switch those parts to WebAssembly.
Okay, great. Thanks for your this presentation about like DevStandup. Like I really like that. And guys, as I mentioned, like we are having like basically each week like one DevStandup, and like our guest speakers talk about their experience and gives basically some kind of masterclass like what they did. And also, if you would like to be our next guest speaker, please fill in the form in the description below, and our team like will contact you, and you can be our next guest speaker and share your experience in your favorite topic. And yeah, that's it. Thanks for watching for the Dev Stand Up, and see you in our next Dev Stand Up episode. Take care. Bye bye.